All right, welcome. Let's get right into it. Today, we are putting on our ethical hacker hats to really dig into one of the most crucial skills in all of cybersecurity, network scanning. This is the bedrock, the absolute foundation for seeing a network the way a security pro does.
So, have you ever really wondered how an attacker sees your network? I mean, to you, it's probably just websites, apps, the usual. But to them, it's a landscape. It's a map full of doors, windows, and potential ways in. And their very first step is always to draw that map.
And that whole map-making process, well, that's called reconnaissance. Or, as you hear all the time, just recon. This is the first and, you could argue, the most important phase of any security audit or attack. This is where you gather the intel that dictates everything you do next.
Honestly, the best way to think about it is like a heist scene from a movie. The crew doesn't just run into the bank, right? No way. They watch the building for weeks, they figure out the guards' schedules, they get the blueprints. Reconnaissance is that, but for the digital world. We're just swapping out blueprints for IP addresses and floor plans for data packets.
Now, this recon stuff kind of splits into two main flavors. First, you've got passive recon. This is like using binoculars from a mile away. You're just gathering public info, stuff on Google, social media, whatever, without actually touching the target. Then there's active recon. This is where you walk right up to the building and start rattling the doorknobs to see which ones are unlocked. You are directly poking the network to see how it responds. Okay, so to understand how to rattle the doorknobs, we first have to understand the language computers use to talk to each other. The absolute backbone of pretty much all internet communication is something called the Transmission Control Protocol, or TCP. And every single TCP connection starts with a polite little digital introduction.
And that introduction is called the three-way handshake. It's a super simple three-step dance. First, your computer sends a little packet called a SYN, which basically says, "Hey, you there, can we connect?" If the server's listening, it sends back a SYN-ACK packet, which means, "Yep, I hear you, let's do it." Finally, your computer sends one last ACK packet saying, "Awesome, got your message, let's start talking." And boom, connection established.
So when we scan a port on a server, what we're really doing is trying to start that handshake, and the server's response tells us everything we need to know. If it sends back that SYN-ACK, we know the port is open. If it sends back an immediate reset packet, we know it's closed. But what if we get nothing, just silence? Well, that usually means the port is filtered, probably by a firewall that's just straight up ignoring us. All right, so theory is great and all, but how do we actually do this? Well, let me introduce you to Nmap, the network mapper. This thing is the king. It is the undisputed, industry-standard Swiss Army knife for network discovery and security scanning. If you're doing this kind of work, you are using Nmap. Let's start with the absolute basic command. Just Nmap and then the IP address or domain name you want to look at. This runs a default scan. Now, it doesn't check every single port. That would take forever. Instead, it smartly checks the top 1,000 most common ports. It's the perfect first pass, quick, efficient, and it often tells you 90% of what you need to know right off the bat. But what if you're a completionist? What if you suspect a critical service is hiding on some weird non-standard port? That's when you bring out the -P flag. This tells Nmap, hey, forget the top 1,000. I want you to check every single one, all 65,535 of them. Now, fair warning, you're going to want to go make a cup of coffee because this one takes a while. But hey, it leaves no stone unturned.
Now, finding an open port is one thing, but the real treasure is finding out what's running on that port. That's where the SV flag comes in. This is for version detection. Nmap will actually probe that open port to figure out not just the service, like a web server, but the exact version number. And why does that matter? Because an old, outdated version of a piece of software is like a giant flashing neon sign for a potential vulnerability. We can also get a little sneaky and try to figure out what kind of computer we're talking to. The O flag enables operating system detection. Nmap does this by sending a bunch of really cleverly designed, kind of weird packets and then analyzing the tiny little differences in the responses. A Windows machine just responds a little differently than a Linux machine. It's like identifying a car make and model just by the specific sound of its engine. And finally, for those times when you just want to know everything, right now, there's the aggressive scan. The A flag is basically a super command. It bundles together OS detection, version detection, some basic script scanning, and a trace route all in one go. It's incredibly powerful and gathers a ton of info. The catch? This scan is loud. Any decent security system will see it coming from a mile away. So it's not subtle, but man is it comprehensive.
So you've run the scans, a wall of text flies across your screen. Now what? Look, running the tools is the easy part. The real art, the real skill, is in looking at that output and understanding the story it's telling you. This is how you turn raw data into actual, usable intelligence.
So you'll get something that looks a lot like this. You get these nice columns, port, state, and service. So here we can see port 22 is open and it's running SSH, that's for remote logins. Port 80 is open with HTTP, that's your standard web traffic. And port 443 has HTTPS, the secure version. Just from this simple little table, we now have a crystal clear snapshot of what this server is offering to the world.
You know, before you even start looking for open doors, you might want to just see who's even home on the network. That's called host discovery. For that, you use a ping scan with -SN. This command doesn't check a single port. All it does is send out a quick ping to a range of addresses to see who answers back. It is literally the digital version of shouting, "Is anyone home?" into a building.
Okay, so far we've been wearing our black hats, playing the part of the attacker. Let's flip the script. How does all this look from the other side of the fence? If you're a system administrator or a security analyst, how do you defend against these exact techniques?
Defenders are not just sitting around waiting to get scanned. No, they have firewalls set up to block or filter the kind of traffic we've been sending. They have intrusion detection systems, or an IDS, which are basically super sophisticated digital burglar alarms trained to spot the exact pattern of a network scan and scream for help. And maybe most importantly, they're watching their logs, looking for those telltale fingerprints of someone like us, methodically checking all of their digital doors and windows.
So, let's end on a practical question for you to think about. You've run your scan, you see it right there, port 22, SSH, state, open. So what? What's the real risk of having that port exposed to the internet? And if you're the one in charge of securing that server, what is your very next move? The answers to those questions, that's the core of thinking like a defender.